Hello everyone, in this video I'm going to show you how to do customer segmentation, and for that I'm going to use Kmeans, which is a clustering technique. What we need to do first is that we need to retrieve the dataset, and as well this is going to be somewhat of a dataset that we need to prepare, and this preparation will take a bit of time, so please be aware of that, but I really hope it's going to be a fun journey. So the first thing is that let's go to Google and to get this dataset. So what I would like us to Google, so customer Kaggle, and I already have it here, and let's go to the second ones, and in here, so what we need to do, we need to download. You can do a lot of things with dataset. You can do classification problems. You can also as well do some kind of regression analysis problem. It is really up to you because it's really a rich dataset. So what I'd like us to do is to download. For Kaggle, you do need to have an account, which I do. So I'm just going to click on download, and it downloads. So this archive. And there are plenty of things here. So there's test train, because it can also be used for machine learning problems. Since I'm just doing the clustering, I'm not going to use this test and train. I'm just going to simply use the train. Now I'm going to do Control X over here, and I'm going to put it in my desktop. I already have here the train, so I'm just going to replace it, but it's so that you know that I've put it on my desktop. So let's go back now to R and what we need to do. So I've put it on my desktop, and one easy way to get it is to set the working directory. So we go to Session, Set Working Directory, choose Directory, and then very simply in the desktop, I'm going to click on Open. Now as a comment, I'm going to do get data. And if we see here in the files, we see that our train is actually here. So data, that's what I'm going to call it. And then read.csv, open parentheses, open quotes, and then train.csv. Now let's do Control Enter to run. Here we go. We see our data over here. Let's have a look. So we have ID, gender, ever married, age, graduated, profession, work experience, spending score, family size, and we have var1, and then we have already the segmentation that has been done. One thing that I immediately notice is that there are so many A's, and this is something that we need to take care of. Since I don't really know the dataset and I just want to show you how to use the clustering, I'm going to get rid of them. So this is the first part. As well, if I click here on this button, I see that there is plenty of character variables. So we do need to transform. For the Kmeans, it only accepts numerical variables. So this is something that we need to pay attention to. So let's start. And the first thing is that we have segmentation, variable, ID, gender. So there is a lot of data that is simply not useful in order to do the clustering. So in order to do the segmentation. That is the first thing that I want to take care of. So simplify the data set as a comment, and very simply. So we'll still call it data. So we'll do this transformation upon our data. And now we go to our data frame that we have created, open the square brackets, do the comma to signal that we want all the rows, and we are just about to touch the columns. And let's have a look again. So ID I don't want, so starting on the second, and let's start. Now up until is with a colon. Now again to data, we have 11 variables, but I don't want the segmentation nor this var1, which is not something easy to understand. So let's go again. So up until the 9th, because we don't want the last two. Let's do Control Enter. Here we go. It has been simplified. One very simple thing to have a feeling for the data is to use the function summary. And then again, Control Enter. Because they are characters still, we see that there is no profession. For instance, gender, ever married, as well the graduated. So these are all characters that we need to transform. If they were factors, we would have this amount of. each type. Nonetheless, for me, gender, ever married, graduated, or spending score, this is something that for me, it's a no-brainer. So we would have most likely gender as binary in this type of data set, ever married, again, binary, graduated as well, binary, spending score, I think we have around 3 levels. So low, average, high. So everything is pretty clear. But what I think is very relevant is to understand how many professions do we actually have. And why is that? Because if we have here 50 types of profession, then it just makes all of our clustering a bit more complicated. If it's less than 10, then all fine, let's go with it. If it's more than 10, then we need to think of a way in order to work with this profession variable. Now, how do we find out? We use the function unique, which will tell us the amount. So we go again to our data, $, and then profession. Let's do Control Enter. And we see here that we have 1, 5, 9, so 10. We have 10 in total, so that's completely fine. One thing to take in consideration is this blank. And this blank is simply not good. So it's different than an NA. It's just a blank character. Of course, in practical terms, there is literally no difference, but from a coding perspective, there is a difference. And this is something that we need to take care of. And if I am to have a look, and another thing to take in consideration is that these blanks may not simply be a unique case for the profession. So we're going to do this quantity exercise in which if there are some kind of blanks, we're going to transform all of them into NAs so that it makes all of our life a bit easier, because we know when there are blanks, they will become NAs and everything is the same. So how do we actually do this? And as a comment, so transform blanks into NAs. And here we go. So how do we actually do this? So the end goal is into NA. So what we need to put here on the left is some kind of condition that shows whichever are the cells that are blanks. So again, everything is within the data. And this is, I think, very clear. Now, what we need to include inside is just this logical condition that will show when there is blanks. And how do we do this? So data equals, and then very simply the blanks. Again, I think overall the logic behind it's not so complicated. We go to data and we include this condition when it is blank, and when it is blank, then it is an ace. Now let's do Control Enter. Here we go. And what do we need to do next? I want to remove all kind of NAs, because when it comes to the clustering, it doesn't deal well with NAs. So everything or all observations that would have NAs, they will just simply be omitted. If you know well the data set, there are plenty of other ways to transform the NAs into some other values that make a bit more sense. Now, how do we remove the NAs? So again, we go to our data. So this is what I want to be transformed into again. So always replacing this data by a new version. And now I want to go to data, and then here I do complete cases. So this is literally when all observations have values in all of the variables. Now, complete cases of data in the rows, and here we go. And let me do here a comma. Now, when it comes to the commas per se, I don't want it to do anything. I just want to take care on the row perspective. And if I simply do Control Enter, it eliminated quite a bit of our initial data set, but we have learned how to get rid of the NAs at least. Now, what is the next step? Now we're going to start to build the data set. One very important thing, as I mentioned, to do the k-means is that everything that you have must be some kind of numerical variable. Ideally, they are continuous. If they are binary, it's an issue, but there are some ways to deal with this. For instance, if you use PCA. I'm going to keep it simple. I'm just going to do everything that is numerical. Now, how to do that exactly? So the first thing is that as a comment, so start building the data set. And what I'm going to do first is that I'm going to start by immediately isolating the variables that are numeric. And after I do that, I'm going to take care of the variables that are not numeric. And now, yes, I'm going to call it data set. So I'm going to leave this data, which is going to be my go-to whenever I want to retrieve a new variable. And everything that's going to do bit by bit is going to be put into the data set. And as well, and this is something that I have forgotten to do, is that I need a specific library for this. It's likely that you already have it. So it is the dplyr library. And in fact, if you don't have it, please do install packages and then do dplyr. How do you actually know if you already have it? You can simply go to packages and here you can search for dplyr. And here we go, I already have it. So even if you click it here, you can actually do the command library. Now let's continue, leaving this one as a comment for future replication. And now to select only the variables that are numeric. To use dplyr, it works with a different format than the average R formula because we always start here with the data source. So where is all this data that we want to work with? And for us, we know it is within data. Next step is that we need to include here a pipe. And the way that this pipe works is that it's going to tell R that everything that we do after this pipe is related to the data. And after the pipe, then yes, we do this select if. And now if is numeric, I want it to be selected. And if not, I don't want it. But we just need to do this. So to recap, we go to our data and we select if it is numeric. So overall, quite simple. Let's have a look. And here we go. We have our data set with only 3 variables. Now, whereas in our numerics, they have already been done for the character variables. And here I'm going to isolate them in a different format. So character. And what I'm going to do is that I'm going to exactly copy paste what was done above. Here you go, Control C, Control V. And now the difference is that instead of is numeric, we do is character. And this is so that when it comes to now dealing with the character variables, it's quite simple because we just have one dedicated data frame that we know is only related to the character variables. So here we go, character, and it has 5 variables plus the 3 that equals the initial 8. Now, what do we do with these character variables? For me, they are mostly on almost a binary kind of way, with the exception of profession, which is more of a factor-based variable. But remember, Kmeans, everything has to be numerical, and as such, we're also going to be transforming the profession into a numerical variable. Now, to do this, so transform character into numerical. So, and I'm going to do /dummy. There is this very cool library, which is called fast dummies. I already have it. So again, I'm going to leave it as a comment and I'm just going to do the command library and then fast dummies. Here we go. Let's do Control Enter. And now to do this, I'm going to work upon the character that we have just created and arrow. And I'm actually going to use the function dummy and then underscore calls. And what do we need to include inside? Let's just simply do F1 for a quick view, increase the size over here. So there are 2 things that I'd like us to include. One is absolutely mandatory, which is the data, which for us is character, comma. And then what I would highly advise is for you to remove one of the dummies, because you do know that if you include all of them, you fall into the dummy variable trap. And this function already has this in place so that it removes one of them. Personally, I'm most inclined to remove the most frequent dummy. I think this way it creates the best baseline. Please remember that the omitted dummy variable is sort of the baseline to which all the others compared to. And how to actually make this work? So remove most frequent dummy and then equals true. Here we go. Let's do Control Enter. And if we go and we have a look, now our character is actually become much bigger with a lot of dummies. Unfortunately, it still has all this, gender, ever married, graduated. And the next step, when we actually now finalize the data set, now we need to take that in consideration. So data set, that's what I wanted to be called again, and how to work this. So cbind to do column bind. And the first thing is the already data set, which has the numerical variables. And then afterwards, we go to our character. And then I am going to do this square brackets. I'm going to do a comma because I just want to take care of the columns. And again, 1, 2, 3, 4, 5. I don't want the 5. So I want from the 6 up until the last one. And how to do this in a very simple way, 6 to 18. Here we go, Control Enter. And now, yes, we have our data set absolutely finalized. Just one last thing to really finish with all the necessary premises in order to best use the Kmeans is that we need to scale the data set. So we need to normalize everything. Now, how to go at it? So data set, square brackets, comma, and then 1 to 18. And this is so that if we don't specify this, if we just do data set and then scale, what it's going to do is going to create a matrix or a large matrix. And I don't want it to do that. I want it to continue to be a data frame. So this is just rather specific. Again, data set, open the square brackets, comma, because we're just dealing with the columns, and then 1 to 18. All right, there is a mistake because it's not 218, but rather 216. So please, let's correct this. And here we go. And now, yes. Now, to implement the Kmeans, what we need to do at first is that we need to include immediately the number of clusters. So in our case, how many segments do we want it to have? And we're going to simply do the elbow rule, which we're going to see visually how many clusters should be. Just for you to know, when it comes to clustering, I would advise you that clustering is like an art. So there's no proper scientific way. These are just basically rule of thumbs. So like the elbow rule. So determining the amount of segments. I'm gonna need a specific library for this. So install packages and then fact2 extra. And here we go. I already have it. So again, leaving this one as a comment. And then very simply library and then fact extra. And here we go. Let's do Control Enter. And now to do this, so we need to use this function, which is fthis, and then underscore, we do nb clust, and what we need to include inside. So again, let's do F1 to have a look, and let's increase the size. And here, let's have a look. We need to include this X, which in our case is our data set. Next, we want to include the type of clustering. So this fun cluster, which for us is the Kmeans. And then lastly is method equals. And then what we do is that we open quotes, WSS, so weighted sum of squares. Now let's make it a bit pretty. So labs, and then just simply subtitle equals, and then elbow method. Here we go. And let's do Control Enter to make it work. And if we go to the plots, it will eventually appear here. While it is not here, let's start to prepare the next step. So clusters. So this is when we do the clustering overall. We're going to call it again clusters. We're going to do an arrow, and we're going to use the function Kmeans. And what we need to include inside Kmeans. So there is the data set that we need to include, and as well the amount, which I'm going to do it immediately now. So this was a great timing. And let me zoom in. And again, so how do we do the elbow rule? So when it's bending, this is the amount of clusters, which for us is 6. So very simply, I would also say that for this specific kind of elbow rule, this is quite rare, because at least for me, in my professional experience, there's never been a time where this elbow rule was, obvious. It was always like, iffy, or, or you could choose almost like 1/3 of the options of clustering, because the option was really not obvious. But for us, it is 6. So here we go. Let's do 6. And as well, now that this is done, let's also do F1 to have a look. So X, which is our data. Centers, we have just specified, which is 6. And then we want to do this iter max, which I'm going to leave as 10. K-means works in an iteration based way. So to make it less processing abusive. So it's going to try to create 6 clusters and then going to try to optimize based on that. And as such, let's do Control Enter. And then you would immediately see that the process has been done. And we see here, so we have the clusters. And now, how do we actually do this? So to access the characteristics of our clusters, we do clusters and then $centers. Here we go. And then we see here per cluster the characteristics. Now, how do I actually do this? If I were to just use this, I'll just simply put this on Excel and then do some conditional formatting, which is exactly what I'm going to do. So write.csv, and inside I'm going to do this clusters $centers. And then I need to include file. So file equals, and then I'm going to call it clusters.csv. Before we do that, I'm pretty sure that you're curious. Now, if you wanted to attach each customer to a cluster, what would you do? For me, the simplest way would be to add it to the current data set that you have. And here we go. So we need to replace the data set, and then we are going to do cbind. And again, inside cbind, we include our data set. And then we go to the clusters that we have just created, and then $cluster. And if I do Control Enter, what we see here is that we have one extra variable. And inside we have here our clusters. So this is how I would attribute each cluster to a customer. But for me, what we're going to do next to finish up this video is that we are going to have a look at the characteristics of each of our clusters. Let me do Control Enter because I have not done so. And please do as me and just open the file. And now let me go to the Excel. Now to work from this, so we have a lot. So first and foremost, let's simplify this and just put here the 2 values. Let's go to the conditional formatting. Let's create a new rule. So highlight cells that are between, and let's do between minus 0.35 and 0.35. Now how? I really just want to completely hide them. And how? I'm going to put here full black. Here we go. Now, much better. Now, why am I doing this? Is that it is really in the extremes that you define the segments. So if you have values that are very, very low, so that are, very close to zero, then these values are not so different from the overall average. So you really want to characterize based on the extremes. So let's have a look. And which one has the least? I think that's the easiest way to kick it off. It's the fifth one. And the fifth one is characterized as being male-driven and being entertainers, and definitely not healthcare. But, healthcare overall has all of the variables, so I don't think that's so relevant. So I would call segment number 5 male entertainers. Here you go. And let me do like this, and let me wrap text so it makes it a bit more readable as well. And I'm going to do the same to the upper part. Now, what we want to have a look next. So we have done the male entertainer part, and what is next that we can definitely also have a look at. Let us do the fourth one. So we have young doctors, and not entertainers, not overall healthcare apparently. So I'm going to do young doctors. Next one, let us do for instance, the first one, which has plenty. So we still have young over here, very young, with a high family size, not married. So we have single parents, apparently, or rather yet single young parents who have not graduated and are healthcare. As well, we see that the spending score is not average. Now the question is, what kind of spending score is it? And we also know that it is not high. So to recap, we have young single parents that work in healthcare. So the healthcare would be before parents, so healthcare. Now, of course, I'm stating that high family size means that they are parents, and of course this may not simply be true. It can also be related to households, but just for you to understand where I'm going to. Next, let's do the sixth one. So here we have the engineers, which have a spending score of average. So medium spending engineers. So this is going to be very simply the sixth one. Next, we have the second one. And so we have old. So ever married, yes. I don't think this is so relevant because it can be that they have been married before, and now we don't particularly know what is the status currently. So I'll disregard this part. And we have as well executives or lawyers. And as well, the spending score is high. So old, lawyers / executives. And as well, what we do know that they are whales. So they are high spenders. Which one is the last one? Is the third one. We have again young. Ever married? No. So we have single. We have not graduated. And what we do know of them is that I think they are just literally the young people. No. I'm wrong. So we have here the marketing. So we have the young single marketeers. And here we go. So this is how you go from a data set to some customer segmentation. In the end, we have 6 customer segments. And what you do need to do in the end is that you need to understand to whom should you tailor. So you do know that you can characterize your customers into these 6. Now it's really all about where are they and how are you going to tailor your message, and should you actually even cater your message to all of them. So it's really about the opportunity and what is your product. If you like this video, please do subscribe to the channel, and as well check the Udemy courses that I have. I'm very much looking forward to seeing you in another video, and until then, have fun.